If you have a double bond on your UTME question, what do you need to do? All right, so my name is Mentor Paul on Academy. I'm going to teach you this, but you're going to use your hand and name this, like the answer on the comment section. Go to my YouTube channel. The name is Mentor Science and Arts. That is the name on YouTube channel, Mentor Science and Arts. Search for this on YouTube. Subscribe to YouTube channel. You're going to see a compiled tutorial on different topics from Jamb question. All right, now you can WhatsApp me on 081 539 57022. This is my WhatsApp line. I'm going to add you on my online WhatsApp channel group where you're going to be seeing tutorials on different topics and subjects and past questions and the tips you need to follow to be able to meet up to the 40 seconds you have in your jam for each question. Now, this particular question you have above here says the IUPAC nomenclature for the compound above is what? Now, when you have a double bond, this is from what? Alkane. You know that already. Alkane. We also have alkyne, which is what? Triple bond. Now, what you have to know is that apart from alkane, which is what? Single bond. Apart from alkane, each of these other bond have higher priority than any substituent you're going to have. What do I mean by priority? Now, I want us to go on to name this. But before that, if you have 4 carbon, this is a 4 carbon. This is a what? Double bond. This is a single bond, I mean to say. The name of this carbon, they are 4. Because they are 4, it is what? Bute. And because they have what? Single bond have on them, they are what? Ane. Because they are family of what? Alkane, having what? Single bond, butane. Now, assuming this structure here has a what? Double bond over here. And then, what is going to be the name? Again, we know that it has what? 4 carbon, names as what? Bute. Now, this double bond shows that it is what? Alkane, ending with what? E-N-E. So the N will now become what? E-N-E. So the name of this structure is what? Butane. But if I should ask you, go to your room, get me a butane, and you go to your room, you found this on your room, you found this, and you found this. According to what I said, this is what? 1, 2, 3, 4, bute, double bond in, butane, 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 butane. So you found this. Which of these are you going to bend for me? Now you're going to be confused because the in, which is double bond, is located at different places on the bute of the structure I asked you to go and bend. So for you to not be confused, because you cannot just bring any of this structure because of their different location of what in we are having. So for you to be able to notice it, I have to give you a specific number of carbon where you are going to locate the what? The double bond. Because of that, we do number forward 1, 2, 3. All right. Now we also number backward so that we can find the number, the phase that give us the lowest possible what number. Now from this phase, which is the what? Forward locant, the number is what we call locant. From this phase, which is the forward locant, this double bond is going to be in between carbon 1 and 2. Now in this case, it is going to be on carbon what? 1. We assume that this carbon is what bears what? This, and not on carbon what? 2. Notice it is on in between carbon what? 1 and 2. But because we are throwing the forward locant, it is going to be on carbon 1. This carbon is what bears what? This double bond while we are naming. But this one also bears it. But we assume this one so that you cannot be confused on the conversion of the name to what? The structure. So this carbon bears this double bond. Hence, I'm going to say that this is what? Bute 1A. Meaning what? On that place, you're going to see a 4 carbon. On that 4 carbon, on the first carbon, you're going to see an A, meaning what? Double bond. Now remember that we separate a number from alphabet, which is what? T and E. using a what? A dash or a hyphen. This you can call it build dash one dash in, or you can call it one dash build in. Either this name or this one is the same thing. So you now put the number before the word parent name. So for this one here, we now become what? 1, 2, 3, 4. 1, 2, 3, 4. If I should follow 1, 2, 3, 4, 1, 2, 3, 4. If I should follow this for local, it's going to be on carbon what? 2. If I should follow the backward local, it's going to be on carbon what? 2. So the name is going to be what? Build dash 2 dash what? In. This one is what? Built what? Dash 2 dash what? In. Whereas this last one is going to be what? This is where the double bond is. So if I start naming from backward, it's going to be on carbon what? 1. If I start naming from forward, it's going to be on carbon 1, 2, 3, 4. So because of that, this I'm going to choose the what? The backward locant, whereby this double bond is going to be on carbon what? 1. So that this is going to become 1, 2, 3, 4. The double bond is on carbon 1, and it's going to be what? Built dash 1 dash what? In. So it is the same thing with this other one here. So if this double bond was located here, it is still going to be what? Built dash 1 dash what? In. If it's located here, it's going to be what? Built dash 1 dash what? In. That is the trick you need to know. Now, after you have noticed this, can you now name this structure in above and put the answer on the comment section? But before that, we are going to see another problem over here. You don't just have the what? Double bond, you have the what? Another substituent. Like I said, bonds have more priority apart from the what? The first alkane, which is what? Single bond. Other bond, which is what? The double bond and a triple bond, has more priority has priority than any other substituent in a what? Organic structure. All right. So what am I going to do? I'm going to give this double bond the lowest possible number. So my longest carbon chain here is 1, 2, 3, 4, 5. Let's follow the branch chain 1, 2, 3, 4, 5. So if I should follow 1, 2, 3, 4, 5, it is still going to be what? 5 carbon. If I should follow 1, 2, 3, 4, 5, it's going to be what? 5 carbon. So I'm going to follow the word straight chain according to my own word, my own way. Because if I should follow the forward chain, it's going to be the same. The branch chain is going to be the same thing. If I follow the straight chain, it's still going to be what? The same thing. So I have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now, in your family, assuming you guys are 5, 1, 2, 3, 4, 5. You are 5 in your family, and this one here is the first born, second born, third born, fourth born, and fifth born. After your mom has finished cooking, he's going to what? Give the last born food to go and give the first born or anyone, but the first born will take food before the second one, before the third one, before it was fourth one, and then finally the last born. Now this is what we call priority, because I told you that double bond have more priority than any structure, sorry, any substituent that is going to be on that particular structure. We are going to give this double bond the lowest possible number. So this number here, you can take it as what? As food. So here I have 1, 2, 3, 4, 5. So this is 2, means that this carbon is going to be on carbon 2 if I should follow the what? Forward locant. Whereas if I follow the backward locant, this double bond will be on carbon what? 3. Whereas this substituent is going to be on what? Carbon 2. So here the substituent is on carbon 2 from the forward locant, and the double bond is on carbon 3. But in the backward locant, the double bond is on carbon 2, while the substituent is on carbon what? On carbon 4. So I'm not going to give priority to this substituent, but I will give priority to what? Double bond. Hence, I'm going to follow the word backward locant that gave the substituent carbon 2, and not the forward locant that gave the substituent carbon 3, as you can see. So henceforth, I'm now going to name this as this something something and something. All right, having known this, let's know your answer on the comment section. But if you still find it difficult, let me know in the comment section. So what is going to be the name? Is it going to be 1,1-dimethyl but-2-in, or 2-methyl-pent-3-in, or 4,4-dimethyl but-2-in, or just 4-methyl 1-methyl pent, no dash, just 2-in? Which of these is going to be your answer? All right, decided to do this so that I'm going to give you another one in case if you don't know. Now, this parent name, this here is the structure. We have now chosen the what? The backward locant. So I want to print this. Let me now name it. So what do we need to know? If I ask you to go and bring this in your room, if you're my brother or sister, I'll tell you, okay, go to the room. You're going to see on carbon 4, you're going to see what? On carbon 4, a methyl. A methyl, because this is what? A methyl. So if you go to your room as my brother or sister, you're going to see on carbon 4 a methyl. And this methyl is attached to a pent, meaning what? Total of what? 5 carbon, which is having what? On the carbon 2 and in, which is what? The double bond. Now remember that we separate what? Number from alphabet using a what? Dash. So this number was separated by what? These two what? Dash. So that in your room on carbon 4, or to make it more easier, I just tell you that in your room there is a what? Pent, which is 5 carbon. In that 5 carbon, on the 4th carbon, you're going to see a what? Methyl. And if you see a methyl on the 5 carbons, don't forget that on the carbon 2, you are going to have what? E-N-E what? E, which is a what? In, and a double bond. The reason for this is so that you can be able to convert from the name to the what? Back to the structure. So assuming you are not given this structure, let's emphasize on that, because sometimes you're given the name, they ask you to what? Find a structure. If you're not given this structure and you're just given this name, how will you use this name and go back to the structure? Let's do that. You start from the what? Parent name. What is the parent name? This is a what? Substituent. For-methyl is a what? Substituent. But this other one is a what? Parent name. Now the parent name is what? Pent, meaning what? I have 5 carbon. 1, 2, 3, 4, 5. Let's go. And this parent name has dash 2 dash. It means that there is a what? On carbon 2, I have a meaning what? Double bond. So which of these will be my carbon 2? This is carbon 1, carbon 2. This is carbon 1, carbon 2. So what did I need to do? Whichever way you follow to put this carbon 2, it is still going to be correct. Now we notice that this 2 in on the initial structure was located here, so that we count carbon 1, carbon 2. This was where the in is, and the methyl, which is CH3, is here. But assuming you don't know that that structure exists before, and then you are now going to find 2 and put in carbon 2 and put your in. If you choose this as your carbon 2 and then you put your in here, is still what? Correct. Now let's do that. So that I'm starting from here. This is my carbon 1, this is my carbon 1, 2, I have in. That is the complete what? The parent name, which means that this other carbon we have what? Single bond. And if they have single bond, they must have what? H, have H, have H, have H. Now for this H, there's already, for this carbon, there's already one bond here. Remaining what? 1, 2, 3, which is going to be filled with what? Hydrogen. So that hydrogen is going to fill what? 3 places. So they're going to be what? 3 hydrogen. Now this one has 1, 2, and 1 over here. So we have not finished for the structure. So we still have a what? A substituent. Before that, let's put the substituent. We have 4-methyl. So you ask yourself, where is going to be carbon 4 and you are going to find a methyl, or you're going to put a methyl. So since we have started numbering from this forward locant, we are still going to continue like that. So this is carbon 1, carbon 2, carbon 3, and carbon what? 4. I have a what? Methyl over here. So that is the structure we have. This carbon have CH3 because after this, 1, 2, 3, and 4. Hydrogen, hydrogen, hydrogen. So that is it. But we put it as CH3. It's the same thing. This is what condensed structural what formula. Condensed structure I mean to say. Now this other carbon here has what? 2 bond, 3 bond, remaining what? Hydrogen. This other, then this one, remaining hydrogen. This one, 1, 2, 3, just hydrogen, which is going to put here. So this is what? The structure that bears what? This name. Remember the other one, methyl was here, and the double bond was here. It is still the same thing. All right. So this, you have gotten it what? Correct. Now, after knowing this, I want you to try this question. Try this other question. Let me know your answer in the comment section. I have C, 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 and C. 1, 2, 3, 4. 4 is too small. C, C, C. I have 1, 2, 3, 4, 5, 6. That is 6 C's. Now I have here double bond. I have here double bond. I have here column. I have here bromo, and I have here methyl. So try this structure. You have 2 double bond, 3 substituents. Let me know the answer on the comment section. Let me just remove this methyl and make everything to be on a what? Halogen group. Let's have fluoro over here. So here, fluoro, chloro, broro, and 2 double bond. Let me know your answer in the comment section. And like I said, if you have any question, let me also know in the comment section. So that is the name. And if you look very well on this option, which option has this name? So this is what 4-methyl pent dash pent 2 no dash in it. So because none of this is correct because of what it bears, we are going to take this and assume that the absence of dash is from what? Computer or an error. So this is still going to be what? The answer. Now, this is what you're going to put on the comment section. Don't forget to share this video, please, and like. Bye bye.